is a vodcast to support the formative quiz for Activity 9. There are 6 questions concerning logs and indices. First of all, we're asked to simplify a to the power 5 times a to the power 2, or a squared. Well, we can either think of this in terms of the indices rules. Well, in this case, the expectation is that we would add the indices, and that would give us a to the power 7. Just to confirm or see why that's the case, well, a to the power 5 just means 5 a's multiplied together. You can use a dot to represent multiplication. So there's our 5, and then that's multiplied by a squared, which means another 2. In other words, we've got 7 a's multiplied together now, which we can write as a to the power 7. Hence, the rule of addition of indices works. Second question, we have a to the power 5 divided by a to the power 2. In this case, we use the subtraction rule. So we subtract the lower power 2 from the upper power 5. Or, we could write that as a to the power 5 over a to the power 2. It's the same thing. Subtract 2 from the 5 gives us a to the power 3. And just to confirm that, well, a to the power 5 against 5 a's multiplied together, divided by a squared, well, that's 2 a's multiplied together. And that means we can cancel 2 of the a's top and bottom, because a times a divided by a times a is just a 1, and therefore that leaves us with just 3 a's multiplied together, which is a cubed. Next question, we're asked to simplify log a minus log b plus log c. We could use 2 log laws here. Combine log a minus log b, that's going to give us log a upon b, and we still have the plus log c. If we add 2 logs together, we can just combine the 2 arguments by multiplying them together, so we end up with ac upon b. To try and get a sort of confirmation that that's the case, if we imagine that we had let's say a was 10 to the power 9, and b was 10 to the power 3, and c was 10 to the power 5. Well, we know that we'd end up with a upon b here. Well, 10 to the power 9 divided by 10 to the power 10, that's 9 tens multiplied together, divided by 3 tens multiplied together. We cancel 3 of the 10s, top and bottom, leaves us with 6 tens multiplied together. So that would be 10 to the power 6. And if we then combine those 2, we would have 10 to the power 6 times 10 to the power 5. In other words, 6 tens multiplied together multiplied by 5 tens multiplied together, which is 11 tens multiplied together, which is 10 to the power 11. And so we end up with log of 10 to the power 11, which is just 11, assuming that we're using base 10. So using our log laws, that would have been log of A times C divided by B, and using our indices rules, that means we would add the 9 and the 5 to give us 14, and then subtract the 3 to give us 11, which we see does indeed work. Our next question involves change of base. We're asked to state log to the base 2 of 10 to 2 decimal places. And one way to remember what to do here is consider that the 10 sits slightly above the 2, and we always take the log to the base 10 of the figure higher up divided by log to the base 10 of the base 2 in this case. The next question involves a fractional power or index. We have 27 to the power 4 upon 3. And the thing to realise here is that this could be rewritten as 27 to the power 1/3 to the power 4, because 4/3 can be rewritten as 1/3 times 4. Now I've written that as 1/3 times 4 instead of 4 times 1/3, because we ought to be able to spot that the cube root, that is 1 upon the power 1 upon 3, cube root of 27 is 3. Now remember, the cube root is simply what gets multiplied by itself 3 times, or what there is 3 of multiplied together to give us 27. Well, that's a 3, because 3 times 3 times 3 gives us 27. So this becomes 3 to the power 4. 3 to the power 4 is the same as 3 to the power 2 squared. 3 to the power 2 is 9, 9 squared is 81. The last question concerns negative power. How do we rewrite 3 to the minus 3 with a positive power? Well, negative power can be rewritten as 1 over the positive power, and so that gives us 1 upon 27.